So here's the project today. This is the base of a standard wood plane, and it was sent to me by a fellow YouTuber, and there you see the problem. I asked him if he'd send it to me so I could practice welding on cast. It's 1/8 inch thick cast web is going to be quite the trick, especially for somebody that doesn't weld. First thing I have to do is come up with some kind of welding jig to hold it rigid. This is a piece of 2.5 inch quarter inch wall square tubing. Now what I'm doing is I'm going to flatten one side as the best I possibly can on my belt sander. The purpose will be for two reasons. One, I want a nice flat surface to jig up. And the second part is I want to use this also as a thermal mass. When I preheat the cast, I'm going to put this in the oven with it. So it and the cast iron will be brought up to around 400 degrees before I start welding. And that extra mass of steel right there is going to keep the cast iron hot while I'm welding it, hopefully so that it won't cool too fast and crack. Those thin webs are going to be a problem. Here I'm just checking to make sure I got a nice flat finish. It's as flat as I could possibly get with my belt sander. There's no light coming underneath that scale, and that's a good sign. Did a pretty good job. I'm happy with that. It should work just fine. Here I'm just mocking up the jig that I'm going to use to weld this piece of cast iron back together. I'm working this out ahead of time because this whole thing is going to go in the oven, and when it comes out it's going to be about 400 degrees. I don't want to be fumbling around trying to figure out how to clamp this thing together. At the same time, I don't want that cast to cool off too quick while I'm trying to weld it. I tried welding cast many years ago, a complete disaster. And this is a chance to try and learn to do this. Okay, so what I'm doing here is I'm using a flap disc, and I'm going to bevel the edges of the web of that plane. They're only an 1/8 inch thick at the top of that web and about 3/16 near the base. That's all the cast I have to work with. So I've got to put a bevel on it so I get good penetration. At the same time, I can't go all the way through. I have to have that fracture line of the casting so that I can put it back together and it'll lock in proper alignment. Here you can see what I've done. Now I've also I ground about maybe a 1/2 to 3/4 inch up on the web on the inside so that I can get a good tack on the inside of the web. The idea being is once I clamp this thing together, I can put 2 tacks in there, and then I can pull the clamp out of there and work on the thing without too much trouble. So there you can see the bevels a little bit. There's nothing to weld on the bottom except a little bit of the corner. So all I can work with is the webs. And you can see just a little bit in there. I'll point to it right there. You can see I ground away a little bit on the inside so I can get a good tack going in there. Now this is gray cast iron. This is not Now here I'll try to get you a little bit better picture, a still picture I can include in here so you can see what I've done. A little more clarity on the webs as I ground them and prepped them for welding. You can see I'm really close to where that blade comes through the bottom, so I can't damage that area. And here's how it goes back together. You can see the V notching I did on that. So let's put it in the oven and get it heated up. Now I'm going to heat this up to about 450. I was going to heat it to 450, let me say that. But the oven, even if you set it for 450, doesn't seem to want to go beyond 400, which is fine. It's the best it's going to get. Now I put this in there for over an hour to make sure I had good saturation. It took about 20 minutes. I got it up to 200, and it took a little over an hour, I guess, hour and a half, to get it to just about 400 degrees, and that's the best it was going to go. So that's what we'll work with. Now remember, everything coming out of there is 400 degrees. So you got it doesn't look hot, but it surely is. Now this is going to be both my jig and an additional thermal mass. Yeah, I nearly grabbed that thing. You could just feel the heat right through those gloves. Here we'll just set it up in the jig, and I'll use my larger vice grips and clamps, and I'll pull it together on two machined surfaces on the inside of that plane. That'll lock those two fracture lines together perfectly. And then I'm going to take and lock the ends of the casting down to the steel. This way everything is going to be as flat and as true as possible when I weld it. Now the rods I'm going to be using to weld this are a nickel-copper alloy. I got them from Purity Gas Welding Supply. They're not for the faint of heart. 1 pound of these things with tax cost me $40. They're a specialized rod that will work with TIG and oxyacetylene. And after talking to the young man at the counter, he really stressed that these would be what I want to use. I had originally considered brazing it. But after talking with him and discussing options, I took a chance on these rods, and I've tested them. I've tried them out with some mild steel. They work really nice. They're a sweet rod to work with. And other than the fact I'm welding on cast iron, they would be very nice to use on mild steel, but very expensive. Nonetheless, they're working really well here. Now I've got my tacks on my inner web, and in a minute I can get rid of that clamp which is in my way, and then I can reposition to weld the sides of the webs. The problem here, of course, is I have to do this fairly quick, because every minute this thing is out of the oven it's cooling, and I'm putting heat into it and it's cooling off at the ends, so there's a lot of stresses being built up as I weld this. So I've got to get it welded quick, and I got to get it back in that oven to bring the temperature back up so I don't get any cracks. At least that's the theory. One thing I've discovered is that I definitely need to get some kind of welding cam. If I'm going to do any videos with welding, I need to get something that I can actually see, or you could see what I'm doing. Now again, I am no welder. I don't even want to play one on YouTube. But the things I like to build require welding, so I have to become reasonably proficient at it. I can't put down the prettiest welds, but they're good and strong. And for TIG welding, I've never ever been able to stack dimes, but I certainly can make the metal weld. Kind of an FYI, I've got my welder set for 105 amps, straight DC, and it's just about the right temperature. I can't I've got enough heat for the casting without the risk of blowing through it. And I'm using a pedal to modulate it. But you can see how much heat I'm putting into that cast iron right there. And right now, remember, the ends of that cast iron are cooling off. Hopefully that piece of steel will supply enough additional thermal mass that it will keep it hot long enough that it won't fracture on me. If anybody out there has tried to weld cast iron, you know exactly what I'm talking about. This stuff is temperamental. I think I'd rather weld cast aluminum than cast iron. And I can actually weld cast aluminum, but this will be the first time that I've ever been successful with cast iron. Now here I'm just adding a little more weld to the bottom of that piece of casting there. And so there's not much material to work with, but I still have to get it welded. I'll grind it away later. Now you can see where I've been welding, it's still 400 degrees Fahrenheit, but out here at the end, look at what I've lost. That's a huge temperature differential. So I need to get it back in the oven and bring its temperature up. And I'm only going to take it to about 400 degrees. Well, that's all I can take it with a silly oven. And then after about an hour, I'm going to drop the temperature down to 300, and then an hour later I'm going to drop it to 2, and then I'm going to let it cool off naturally. Now here I'm just using a flap disc. I'm taking down the larger part of the weld, and then I'll take it over to my 6-inch belt sander and flatten it out. Just trying to be careful here so that I don't gouge into the virgin cast iron. I just want to knock down the weld so that there's less of it I have to put on the belt sander. This material was surprisingly difficult to grind away. The cast iron is actually, I believe, softer than the material I was grinding on. So it was kind of tricky. There's a couple places I had gouged into the cast iron, and I had to go back and fill those up. That's a pretty good indication. Now here's a quick tip. This is a poor man's Magnaflux. If you're looking for cracks in a weld and you don't have a fancy Magnaflux system, what I use, and works really well, is just a Sharpie marker and a little acetone. You kind of saturate the area you want to check for a crack with a Sharpie, and then put just a few drops of acetone on it, and the acetone will thin that Sharpie down. It will flow into all the cracks in the material, and it will highlight them fairly well. And as bad as my eyes are, I can still find a crack with this method. It works really pretty good. So any place I think there might be a problem, you can see I'm marking it with a Sharpie. And yep, I did find a crack. I'm not going to go back and show you how I fixed the crack, because basically all I did was I ground it out, and I went back and heated it back up. There's the crack right there. I'll give you a better picture in just a second. I'll put a little more acetone on it and make it easier for you to see it. Can you see it right there at the tip of my finger? Little tiny crack. It's coming up the side of the web just a little bit. So what I'll do is I'll grind that out, and then I'll re-weld it once I reheat the piece. Now this is a handy tool. This is my cell phone, of course. It's a Note 9. but it's got a really, really good camera on it. And I can pull some detail shots and really enlarge an area so I can see something I would normally need a magnifying glass or a microscope with. It's a terrific camera. It's a wonderful tool. There you can see the crack highlighted with the Sharpie marker. Again, I just use a Sharpie and a little acetone, and it will work its way in that crack and become readily visible. Anyway, I inspected all around the thing looking for any other cracks. I just found the one. So I was pretty happy with that. I was a little sad that I actually had a crack. I thought I took every precaution to prevent it. But I think I was just out of the oven too long and let it get too cool while I was welding it. Anyway, I fixed it, corrected it, and here's the pictures. Again, I want to thank Matt at the Super Wrench Garage on YouTube. He sent this to me and let me take a chance at fixing it. And it's going to go back to him this week. There's a divot I put in it with a flap disc. See, I told you this casting's soft. And there's a little bit of a pot. I just didn't want to go back and take a chance at heating it up and welding it again and making it worse. That's cosmetic. It's not going to cause any problem. And there's Matt's card. Thanks, guys, for watching. I hope this was helpful and informative. Remember to like and subscribe.
Are we videotaping still? We're good? No, don't put your fingers in front of it, honey. All right, hit stop. All right, hit stop.